Hello Internet, today we're going to be doing a quick tutorial on how to create a OpenCV based solution that allows us to read the corner points of an image. And what we're going to do today is specifically we've got an image in our folder right now, which could be grid PNG, and essentially we've got this grid, and what we want our Python OpenCV program to do is to effectively read all of these points and then put them into a Pandas Dataframe or Numpy array or whatever data format you really need. Now, the reason why you might do this is you might want to grab all these points for like some bigger like Python sketch, or maybe you want to do something with TensorFlow or something like that, something machine learning related. But this will, this doesn't require any TensorFlow or anything. This is just simply OpenCV, Pandas, and Numpy. And for the purposes of this tutorial, I'm going to be using PyCharm to program it. However, you can just use any Python IDE, or you could just use a code editor. Just make sure you've got Pandas, CV2, or OpenCV to be precise, and Numpy installed. So let's actually get started right away. So as we can see, let me just get this right. Okay, so as you see, we've just got a simple main function. So if we run this, we will get executed, as we can see right here, executed. So what we're going to do is we're going to write, or first off, we're actually just going to import our libraries for this task. So what we're going to do is we're going to import pandas as PD, and we're going to import CV2. Now we could do it as CV, but to be honest, CV2 is already quite short, so I just leave it as that. And I will do import numpy as NP. And now we've just got a very, we've got all the libraries that we need to do this task. So what we're going to do is we're actually just going to create the function itself. Well, we're going to be using a method called Harris corner detection. So what we're going to do is we're going to do definition, Harris underscore corner underscore detection. Okay, and we're just going to create a parameter for image. And what we're going to do is we're actually just going to do image equals cv2.imread image. And what this will do is effectively this will effectively give whatever images in here, and it will make it a OpenCV capable image, and we can start doing stuff with it. So what we're going to do actually first is we're going to actually make the original image display first. So what we're going to do is we're just going to say displays original image. And what we're going to do is, I know this is I don't usually program with this like text font, so it's a little bit weird, but hey, it's, new things. Okay, so we're going to do cv2.imshow, and we're going to do, and we're just going to, so this is the title for the window, so we're just going to call it original image, and we're going to tie the image that we've just put in, and what we're going to do is, I think this should work. So what we're going to do is, we were actually just going to put something into main. We're going to put Harris corner detection, and we're just going to put in our file. So it's grid.png. So effectively, the parameter is the file that's already in this folder. So it's grid.png, and when we run it, we should get a okay. Now I know why. Okay, so if we want to keep it displayed, we have to do cv2.waitKey. And that should fix it. Oh no, that did not. Oh wait, no, it's because it's a capital K, right? Look, yeah. Okay, so now we got the original image, and that's kind of what we've done so far. So I know you didn't come in for it, but we're gonna keep this. We're gonna keep this as sort of a debugging tool, and just make sure that everything is working as planned. Next, what we're gonna do is we need to grayscale the image. So what we're gonna do is we're gonna do gray equals cv2.cvtcolor, and we're going to do image, and then we do cv2.color to color underscore bgr to gray. I think it's this. Yeah, no, I think it's this one. Yeah. So we've got bt to gray, and what we're going to do with this, we're going to do gray equals numpy.float 32 great. And what this will do is essentially we'll make some progress. Let's just get some stuff done. So we've got this. So this is grayscale the image, and what we're going to do is we're going to do a simple calculation. So we're going to do distance equals cv2.corner Harris, which is built into OpenCV itself, and we're gonna say gray, which is the NumPy array that we got. We're gonna do gray. We're gonna do 0.1 times dst dot max, and then 255 0. And I think no, we've done this wrong. Hold up. No, that's the complete wrong thing. I'm sorry about that. Okay, no, we do gray 5 3 0.04. Yeah, no, I was doing a function earlier because effectively we have to write this again. So effectively, we're just declaring all of the values for our own little corner Harris function. And what we're gonna do is we're gonna do ret, and we're gonna do dst equals cv2 dot threshold. We're gonna do the dst 0.1 times dst dot max 255 and 0. Boom, we got that. And what we're going to do is, as a little final thing, dst equals mp dot u integer 8 dst. So we're assigning it to an 8 integers, or 8. It's hang on a minute. So ret labels stats centroids equals cv2 dot connected components with stats dst. Now I should probably explain what we've just written because it looks like a bunch of garbage, to say the least. But effectively what we're doing is, so this is obviously grayscaling image, and we're doing the corner Harris thing here, and then we're just tying all of the thresholds of this corner Harris function into this, and we're just declaring it to NumPy arrays, and we're gonna just do some changes. So this will all make sense in a couple of minutes. So we got this. So we got all the labels, stats, centroids. So we got that. And what we're gonna do is we got the next bit, which is gonna be very, very lengthy. So criteria equals. We're gonna do parentheses. We're gonna do cv2 dot term criteria EPS plus cv2 dot term criteria max iteration, and it'll be 100 and 0.001. That's it. And then we've got corners equals cv2 dot corner sub pix. So we're going to be putting the image, which is grayscale, so it'll just be grey. And we'll do mp dot float 32 centroids. Now we'll do 55. Then this will be the window size, and then we'll do 0 zone -1 -1, and then I believe it's just criteria. Okay. So, just to show that this actually works, I'm gonna write a quick for loop to show that it's actually printing out the corners. So what we're gonna do is we're gonna do for I in range of 1 to len of corners, and what we're gonna do is we're gonna do just print corners I. This should hopefully work. Let's hope. Okay, 3, 2, 1. Oh, it did not. Did I make an error? Where is it? Tuple, syntax warning. Okay, so I've just simplified it a bit. I've just made it a much simpler for loop, and there was also an issue where I didn't have a comma in it, so I apologize about that. So now, if we run it, effectively, what was happening was that this should actually be moved down. Yeah, so we should probably just move this down towards the bottom. So what will happen is if we actually X out of it... Oh, no, wait, let's just do it again. Okay, yeah, so effectively, all of these are the X and Y coordinates for all of the corners in this image, which is cool. And what I'm going to do is I'm actually just going to make a simple, effectively an image, just a version of this image with, which is the modified version. So what I'm going to do is I'm just going to do, what would it be? Oh, I know what it'll be. Okay, so we'll do cv2.imshow. We'll do what would it be? We'll just call this modified image, and then it will be dst, And this should work. Yeah, so you can see we got all of these points, which is cool. Now, the final thing we need to do is effectively we just want to just put it into a pandas array. And the way we can do that, or a pandas data frame in this case, because that's what we want. So what we're going to do is we're just going to, let me just think about this. I just need to think about this very carefully. Okay, I know what we're going to do. Okay, so we're going to do this. So for I in corners, we're just going to... Actually, I don't think we even need to do that. Oh, no, we don't. Okay. Okay, this is very simple. So if we want to make it a pandas data frame, what we need to do df, or I'm just going to call it pandas data frame just to make it a bit easier. Pandas data frame equals pd.dataframe. And we're going to do it data equals corners. And the columns will be... Oh, no, that's the wrong one. We don't want that. Equals x and y. And hopefully, what we're going to do is we're just going to print pandas data frame. Just check to make sure it's working. And we're just going to get rid of the other print. Oh, I've already got rid of it. Okay. So now we should. Yeah. So now we got a pandas data frame that is in the proper format. And what we could do is we could just return it. And that's kind of the whole purpose of this function. So what I'm going to do is I'm going to do return pandas data frame. I'm just going to keep it there. And I should probably clean this up, but I'm just going to make it just kind of all one thing. I know there isn't any comments, but actually how now I'll probably just put some comments. Displays the image. Then we can just make this criteria and corner finalization. Okay. Corner method. Okay. And we do return. And now what we're going to do is we're just going to do a simple, we're going to tie this to a variable. So we're going to call this results equals that. And we're just going to print the result. And this should work. Hopefully. Fingers crossed. Yeah. And as you can see, the whole, the entire thing is we've now got all of the corner points as a pandas data frame. Anyways, hopefully that's been a useful tutorial. I apologize for this quite speedy tutorial. I've got some things I need to do, but I want to say huge thank you for watching. And like I say, all the code is going to be available in the description down below. Thank you very, very much for watching. I'll see you in the next one.